Hi friends, welcome to my channel Code Jiffy. In this video, let's learn about race conditions in Java. Okay, so here I have one class with name race condition example. So before moving to code example, let's discuss about race and condition. So a race condition in Java occurs when the behavior of a program depends on the relative timing of events, such as the order in which threads are scheduled to run, uh, which can be which can lead to unpredictable and undesired results. Okay, so let's create a simple uh, example to illustrate a race condition. Okay, so let's proceed, friends. Here I am defining one counter of data type integer, which is private static int counter. Okay, initializing I am that counter to 0. Okay, fine. Now friends, let's create two threads which will increment the counter. Thread 1 equal to new thread. Take a lambda expression here. Add one for loop here for initialize I to 0, where I is less than 1000, means 1 second. Increment I. Increment counter. Save the code. So here I have to create method increment counter. Okay. Let's create, before moving forward, let's create method increment counter. Okay. Because we have called that method here. So we have to define that method first. Okay. So private static void increment counter. Fine. So let's simulate some computation time. Initialize, store the temp to counter. Here I have defined one variable with the name temp, which will store our counter. And let's add one try and catch block here. Try thread dot sleep 1. Okay. And catch interrupted exception E. All the method E dot print stack trace now. Okay. Counter equal to 10 plus 1. And friends, save the code. Correct the method name. You can see that we don't have error now. Okay. So let's proceed for our next thread 2. Okay. So let's define thread 2 here. Thread 2 equal to new thread lambda operator new thread lambda start the lambda expression. Again define one for loop here. Again define one for loop here for int initialize I to 0 where I is less than 1000, increment I, loop body, increment counter, call the method increment counter. Okay. Now let's start the both threads using the start method. Thread 1 dot start. Again thread 2 dot start. Now wait for both threads to finish and add one try and catch block here. Thread 1 dot join, call the join method. Again thread 2 dot join. Okay. Now continue with catch block, catch interrupted exception E. We call the method print stack trace. Save the code. Fine, friends. Now let's write code to display the final value of the counter using the system.out.println method, which will pass the message, which will print the message final counter value. Final counter value plus counter. Okay. Save the code. Friends, we have done with our code. Let's run our code. Uh, Friends, see here, the our output may vary each time when we run the program. Our output will not be same at each execution. Okay, so let's see that. So friends, now you can see that our output is final counter value 1011. Now let's run again our code. So now you can see that final counter value is 1000. If we run again our code, we will get different value again. Let's see that. Okay friends, so now this is the value is 1040. So the our output may vary each time when we run the program. Okay, so the actual output depends on the interleaving of operations between the two threads, and due to the lack of synchronization, it's subject to rest conditions. Okay friends. So friends, it's important to note that in a multi-threaded environment, the outcome of the program may not be consistent. Okay, and different runs may yield different results. So this is a classic symptom of a race condition. So for address this issue, we can use synchronization mechanisms to ensure that critical sections of code are executed automatically. We will learn about synchronization in our upcoming videos. Okay, so this is all about race conditions in Java. Please do like, share, comment, and subscribe to my channel Code GP. Please help to grow my channel. Please add value to my videos by subscribing to my channel. Keep coding, happy coding. Thanks for watching the video. Thank you once again.